Hi, I'm Javen. This subject is Object-Oriented Programming Fundamentals. My team and I will be presenting our project about blackjack card game systems. So the system we built is a console-based game development using Java and object-oriented programming concepts. The reason we chose this blackjack card game system is because it naturally fits the object-oriented programming designs, allowing us to clearly demonstrate concepts such as encapsulation, inheritance, aggregation, and polymorphism. Our blackjack game design system uses multiple classes with different responsibilities, improving readability, maintainability, and scalability. An example is shown here. It has bank, card, dealer, deck, driver, game, hand, normal player, player, and rule engine class. Each class is short and simple, improving readability and also has its own responsibility. Then there is also a rule engine class, which shows the basic game rules such as ace handling, bust condition, and dealer decision logic. So for ace handling, if it is an ace, it can either be 1 or 10. Bust condition is if it is over 21, then you will lose. And dealer decision logic is when if the dealer card is more than 17, then it will stop inputting more cards. So this is the game class. I'll show a demo. So it's first starting off with enter your name. I'll enter Javen. Then it shows the starting balance, which is $100, and then the current balance. So this one is a while loop. So it will continue, keep on playing until you either press quit, which is 0, or your current balance runs out to 0. So first I'll enter my bet, which is 50. It will show me my total value, which is 15, and then the dealer's first card, which is the 5 of diamonds. So I choose to hit, and I got 16, so I will stand. So now it shows the results, which is I win, cause the dealer actually got 25, which is burst. Now I'll go all in with 150. It shows my total value is 17. So, and the first card of the dealer is 9 of hearts. So for the hit and stand, we implemented many try and catch errors. So if we put a value such as 9, it will show an invalid choice because the input only accepts H or S. So now I choose to hit, and then now I stand. And yes, I win again because the dealer's full hand is actually lower than mine. Okay, so I choose to quit now, which is pressing 0. Then the system will actually give us a game over message, and then our final balance is $300.
Hi, my name is Shang Chen, and I'll be presenting our OOP project, which is a blackjack game, and I'll be presenting and explaining the OOP concepts used in our project, mainly encapsulation and also inheritance. So for encapsulation, as you can see here, all our classes have private variables and attributes, and they are accessed through their own get and set methods. So we can see here card actually has a private final attribute. So we actually don't have set methods for this because it's final and we only have uh, get methods to get the each attribute. We also have some set methods and get methods in other classes such as in player. Here we can see we have a name attribute and bank which can be set and also get here. We also have get name here. So that's for encapsulation. For inheritance, we applied it once here in the player class. This is our blueprint or more like an abstract class. We have a attribute hand, and since both players have a hand, and then we have some basic get and get methods, and also show hand, which is abstract and will be overridden in each normal player and dealer. So in normal player, the show hand shows the user their whole hand, shows all their cards they have. And for the dealer, we actually for show hand it only shows the first card, and then after the game ends, it only calls this method reveal full hand to show the whole hand that all the cards that the dealer has. So for we can see here in the code, the show hand is overridden and it prints out the cards that the player has, and for the dealer, the show hand actually shows the first card only. You can get the first index of the array. And for the show initial card, it's actually just to call the show hand just to make it less confusing. And then the reveal full hand will show all the cards that the dealer has. And that's it for the OP concept, which is the encapsulation and also the inheritance used in our project.
Hi, I will explain some of the advanced object-oriented concept in our blackjack game. I will focus on polymorphism, aggregation, and composition, and then I will show the UML diagram to illustrate the system design. Polymorphism allows objects of different type to behave differently even when treated as the same type. In our game, player is the superclass, and normal player and dealer are subclasses. Both override the show hand method. For the normal player, all cards are shown, while the dealer initially shows only the up card and reveal the full hand later. This demonstrates method overriding. A relevant code look like this, and dealer one is like this. So when I run, player will show all the card and dealer will show only up card. The system also use aggregation and composition. A deck contains multiple card objects, demonstrating composition, and each player has a hand, demonstrating aggregation. When the player hit, a card is added to the hand. So I will hit, the card will added to the hand. The once is the dealer's turn, the full hand is reversed. So then we will show the dealer's full hand. These advanced OOP principles make our system modular, maintainable, and extensible. Holomorphism allows different behaviors at runtime, and aggregation and composition clarify object relationship. This design allows us to add new player types or rule without changing the main logic, improving readability and maintainability. At the end of a round, the console shows the player's final balance. Now, I will explain the UML class diagram. In the UML diagram, the player class is the parent class that represents a general participant in a game. Both normal player and dealer inherit from player, which show an inheritance relationship. This allows them to share common attributes, such as the hand, while still having different behaviors during the game. The deck class has a one-to-many composition relationship with the card class. This means one deck contains multiple cards, and the cards are created and managed as part of the deck. Similarly, the hand class also has a one-to-many relationship with the card class because a hand can hold multiple cards during a round. The relationship between player and hand is aggregation, where a player has one hand, but the hand can be cleared and reused between rounds. The game class acts as the controller of the system, coordinating the deck, player, dealer, and rule engine to manage the overall game flow. In conclusion, this blackjack game shows how object-oriented programming principles help create a clear and organized system. By using inheritance, composition, aggregation, and polymorphism, the code becomes modular, easy to maintain, and easier to extend. This design allows new feature or rule change to be added with minimal impact on the existing system, making the application scalable and well-structured. That's all for our presentation. Thank you.